Throughout human history, what we call technology started with simple tools, our brains, fire, and sharp sticks. But the most significant advancement has always come from the machines we built with our minds. Since the 1960s, computers have been getting smaller and more powerful. But this growth can't go on forever. We're now reaching the physical limits of technology. Computer parts are getting so small they're approaching the size of atoms. When we think of computers, we usually imagine complex machines filled with wires and chips. But deep down, computers are made up of simple elements designed to move, process, and control information. The most basic building block is the transistor, a tiny switch that controls the flow of electricity. Information in computers is stored as bits, which are either a 0 or a 1. These bits combine to represent more complex data. Transistors are used to build logic gates. For example, an AND gate only gives a 1 if all of its inputs are 1. With enough logic gates, you can build modules that add numbers, multiply them, and so on. So in a way, computers are like groups of kids solving basic math problems really fast, and together they can tackle anything from physics to video games. But here's the problem. When we shrink these parts down to the size of just a few atoms, weird things start happening. In the quantum world, electrons can tunnel through barriers, something that would be impossible in classical physics. This means our traditional computers stop working the way we expect. That's where quantum computers come in. Instead of using regular bits that are either 0 or 1, quantum computers use qubits, which can be 0, 1, or both at the same time. This is called superposition, and it opens up an entirely new level of computing power. There's another strange quantum feature called entanglement. When two qubits are entangled, changing the state of one instantly affects the other, even if they're light years apart. It's like they're connected by invisible threads, no matter the distance. Quantum computers also use quantum gates, which don't just flip bits, they manipulate probabilities. By linking and modifying qubits through these gates, a quantum computer can explore millions of possibilities at once. Eventually, when the system is measured, you get a final result made of regular O south and 1 south. But that result comes from parallel computations happening all at once. Now, will quantum computers replace your laptop anytime soon? Not really. But in certain areas, like big data, simulations, and cryptography, they have incredible potential. For example, searching through massive databases or simulating molecules could be done in a fraction of the time it takes today. And let's talk about security. Modern encryption relies on complex math to protect your messages, passwords, and bank info. A classical computer would take years to crack these codes. A quantum computer, it could do it in seconds. That's why quantum-safe encryption is becoming a hot topic. Another exciting use is medical breakthroughs. Quantum simulations can help us understand how molecules and proteins behave, something that's incredibly hard for today's computers. This could lead to revolutionary drug discoveries and treatments. In the end, we still don't know exactly how far quantum computers will take us. They might become specialized tools, or they might change everything. One thing's for sure. As we continue pushing the boundaries of what's possible, quantum computing will be one of the most powerful tools we've ever created.